Okay, we are going to do problem 544 from chapter 5, the MOSFET chapter. And the problem says, here is a circuit that has an NMOS transistor with a resistance RS in the source lead and RD. Oh, I'm sorry, this is connected to a negative supply, not to ground. So that's to minus 1 volt supply. And we have a resistance here, RD, and it's connected to the positive supply, which in this case is plus 1 volt. The gate of the transistor is connected to ground. So that's the circuit. And we are asked to design the circuit, that is to find the values of RD and RS, so that we obtain a voltage here, VD at the drain, of plus 0.3 volt. And we also want to establish a current here, ID equals 0.1 milliamp. Of course, there will be the same current that will flow in RS, so that's a current also of 0.1 milliamp. Okay, so that's what we want to obtain. We are given the parameters of the transistor. So we are given the threshold voltage VT is equal to 0.5 volt. We are also given the mu n C aux for this process, and this is equal to 0.4 milliampere per volt squared. Okay, and we are instructed one more thing. We are given the dimensions of the transistor, channel length L of 0.4 micrometer, and W, the channel width, is 5 micrometer. We are also instructed to neglect the early effect. Okay. So, where do we start? The place that I would start is right here, without doing any more calculations. Say that the voltage here is plus 1 volt. We want the voltage here of 0.3 volt. Then we can find the value of RD. Simply RD is equal to 1 volt minus 0.3 volt divided by the current, which is 0.1 milliamp. So that's in volts. That's in milliamp. And that will give me the first answer. The answer to the first quantity RD, namely 0.7 over 0.1, that's 7 kilo ohm. So here we go, very simple. Now, a question then, before we proceed any further, we ask, in which mode is this transistor operating? And the answer is it's operating in the saturation mode. How do I know that? Well, the voltage at the drain is plus 0.3 volts. At the gate is 0 volts. So the drain is higher than the gate by 0.3 volts. And you recall that saturation mode operation is obtained if the drain is higher than the gate, or if the drain goes below the gate, but by no more than VT volts, which in this case is half a volt. So to go back, then this transistor is operating in saturation. Which means now that we can, remember that I'm still trying to determine the value of RS that I need. So to do that, I will need to find the voltage here. Right? That's Vs. And Vs is minus, that's G here at 0, that's Vs. So Vs is minus VGS. So I have to find VGS. To get VGS, go back here, and I will write the square law equation for the FET, which says ID is 1/2 mu n C ox times W over L times VGS minus VT squared. Okay, now ID is 0.1 milliamp equals 1/2 times mu n C ox, which is 0.4 milliamp, same dimensions as the 0.1, so we are okay, times W over L, which is 5 divided by 0.4, times VGS minus VT squared. This equation then I can use to get VGS minus VT. If I multiply it out, then I'll have 2 times 0.1, that's 0.2. 0.4 goes away with the 0.4, so I have VGS minus VT is the square root of 0.2 divided by 5, which is 0.04, which means that VGS minus VT is actually 0.2 volt. That's great. So I know VGS. I'll go back here. So VS is minus VGS. So it equals minus 0. Sorry, we missed something here. That's VGS minus VT. So we have to get VGS as VT plus 0.2, and VT is 0.5 plus 0.2, so that's 0.7 volt. So we'll go in here now and substitute. That's minus 0.7 volt. If I know Vs, then I can write an equation here that says ID is equal to Vs minus the negative supply, so it's minus 1 divided by Rs. And ID is equal to, recall ID is 0.1. So that's Vs, which is minus 0.7 plus 1 over Rs. And this will give me the answer that Rs is equal to 0.3 divided by 0.1, which is 3 kilo ohms. So here are my final answers. That's Rs. And this here is RD. So we designed this circuit, which means we found RD and Rs required to establish the operating current ID and the voltage VD that we were asked to provide.